Hi everyone, today I'll be covering Chapter 5 on short-term memory and working memory. So short-term memory is defined as a memory storage system that is limited in terms of duration and capacity. And we'll see examples of the PowerPoint and how it's limited in these ways. So in the PowerPoint, I'm going to be focusing on four main characteristics of short-term memory. The first is that short-term memory has a short duration. Information can be stored in short-term memory for only about 15 to 20 seconds without rehearsal. When we use the term short-term memory colloquially, we usually refer to our memory of events that happened in the not-too-distant past. For instance, you might sit down to dinner and say, I have a really bad short-term memory, I can't even remember what I had for breakfast this morning. In this case, you're using the term short-term memory to refer to memory for events that happened 10 or 12 hours ago. Again, this is not how cognitive psychologists use the term short-term memory. Instead, we use it to refer to memory for events that happened in the last 15 to 20 seconds. Memory for events that happened longer than 20 seconds ago would be stored in long-term memory, not short-term memory. Let me emphasize that this 15 to 20 second rule is the duration of short-term memory without rehearsal. And by rehearsal, I just mean repeating the information to yourself or out loud. If people are allowed to rehearse, then they can hold information in short-term memory indefinitely. Think about, for example, if you're trying to remember the phone number for a pizza place. You can repeat the digits to yourself over and over again, and as long as you do so, you'll be able to remember them. But again, without rehearsing the information, without repeating the digits to yourself, you can only hold that information in short-term memory and will only be able to remember them for about 20 seconds. The Brown-Peterson task described in the textbook does a good job showing this, so make sure you do that demonstration. Another characteristic of short-term memory is that it is limited in capacity and can only hold about 7 meaningful units. So only 7 or so units of information can be remembered in short-term memory at a time. The digit span task described in the textbook does a good job illustrating this. Basically, the digit span task shows that when you ask people to remember digits, they can remember only about 7 of them at a time. Now, things aren't always this straightforward. Notice in the definition it says 7 meaningful items. What do I mean by meaningful? Well, let's do a demonstration. I'm going to read you a list of letters, and when I'm done, I want you to repeat as many of those letters as you can. So here's the first list. C-I, A-N-F, L-H-B, O-F-S, U. Okay, repeat those letters back. And how many of those letters were you able to remember? My guess is that it was only about 7 letters, the capacity of short-term memory, 7 meaningful units. Now, I'm going to read those same letters again. Let's see if you do any better this second time around. Here we go. CIA, NFL, HBO, FSU. Okay, repeat them. Okay, how many did you remember this time? Well, I wouldn't be surprised if you remembered all 12 letters. So, what's going on? Well, what we are demonstrating is chunking, increasing the capacity of short-term memory by organizing individual units, such as letters, into larger, meaningful groups of units, such as words. Basically, when I read the list of letters to you the first time, I read them in such a way that you could not combine the letters into any meaningful group. As a result, each letter was its own unit in short-term memory. Given the capacity limits of short-term memory, you could only fit the first 7 or so letters in short-term memory before running out of room, and so that's how many letters you were able to recall. In the second list, however, I read the letters to you in groups so that they could form meaningful acronyms. That is, you could chunk each set of 3 letters into one meaningful unit. As a result, there's plenty of room in your short-term memory to hold all 12 letters in those 4 meaningful units, and you probably even had room in short-term memory to remember some more letters if I read them to you in that way. The third characteristic of short-term memory is that information is primarily stored in an auditory or acoustic or verbal code. Your textbook talks about how it's possible to code information visually or semantically in short-term memory, but the default method is verbally. What I mean by this is that short-term memory stores the sound of the items as opposed to, for example, the item's shape. And so, when I give you a list of letters to remember, what is stored in short-term memory is what those letters sound like, not, for example, what they look like. One of the consequences of this property is something called the phonological similarity effect, which says that in short-term memory and working memory tasks, which I'll describe at the end of the PowerPoint, people confuse items that sound similar but look different or have different meanings. If this sounds familiar to you, it's because we used this as an example on the first PowerPoint. I'll read you a list of letters and I just want you to repeat them back to me. So here's the first list: G, T, C, B, D, Z, E. Okay, repeat those letters back. Okay, here's the second list: R, F, X, W, L, K, U. Repeat those letters back. So which list was easier for you to remember? Well, I bet you had an easier time remembering the second set of letters than the first set of letters. The reason the first set of letters were difficult for you to remember was because they sounded the same, and so they were difficult to tell apart from each other in short-term memory, where you store the letters based on what they sound like. Let's do one more demonstration of the phonological similarity effect using words this time. So here's the first list of words: man, cap, can, mad, cad, map. Okay, repeat those words. Okay, here's the second list: toe, pen, eat, big, tie, elf. Okay, repeat those. So again, which list was more difficult to remember? I bet it was the first list of words for the same reason, because the words in that list sound more similar to each other, meaning they're difficult to tell apart in short-term memory. The last characteristic of short-term memory that we need to discuss on the PowerPoint is that information in short-term memory is sensitive to disruption. Let's begin by discussing proactive interference, which is when previously learned information disrupts the memory of new information. Another way of thinking about it is that proactive interference is when old information hurts memory for new information. A study by Wickens illustrates this well. In this study, he had two groups of participants learn 3 lists of items from the same category. That is, he would give them a list of 3 fruits to remember, like banana, pear, apple, then a second list of 3 fruits to remember, grape, kiwi, lime, and then a third list of fruits, strawberry, peach, lemon. What he found was that participants' memory for the second and third list of items declined. This illustrates proactive interference. Having learned 1 or 2 lists of fruit items disrupted people's memory of the second or third list of fruit items, right? Old information hurt people's memory for new information. Now, in this study, Wickens also demonstrated something called release from proactive interference, which is when switching categories produces an improvement in memory for the new material. You can see on the graph that there are 2 groups, the experimental group and the control group. After learning and recalling the first 3 lists, both groups were then given a 4th list of items to learn. The participants in the control group learned items from the same category, so in this example they would be given another list of 3 fruits to remember. The participants in the experimental group, on the other hand, were given a list of items from a different category, like 3 professions, let's say teacher, architect, and salesman. So the question is, how did participants in the 2 groups perform on this 4th list? Well, the finding was that participants in the control group who were given more fruit items to remember continued to have a hard time remembering these items. They continued to succumb to proactive interference. But for the participants in the experimental group who switched categories and learned professions now, they did much better. They showed a release from proactive interference, if you will. So again, release from proactive interference is when switching categories produces an improvement in memory for the new material. We also need to discuss retroactive interference, which is when new information disrupts memory for previously learned information, or when new information hurts memory for old information. So, in class, I have students learn 2 lists of 10 words. One list is normal, as you can see, but in the second list, the 6th item is a curse word. Here's a graph showing how people do on this task. What we're looking at is the percent of words in the different positions that people in my class remember correctly for the words in the control list, the blue line, and for the words in the critical list, the red line. As you might imagine, everybody remembers the curse word in the critical list. But what's interesting for our purposes here is how well people remember the previous words in the critical list, so those that come right before the curse word. Well, what I find is that students' memory for the previous words in the critical list, so those in positions 3, 4, and 5, pencil, boat, and radio, is worse than participants' memory for the previous words in the control list in those positions. So poster, book, and shoe, those in positions 3, 4, and 5. So what we're demonstrating here is retroactive interference. The curse word disrupts people's memories for the previously learned items on the list. So the curse word hurts people's ability to remember the items in position 3, 4, and 5 in the critical list compared to their memory to remember the items in positions 3, 4, and 5 in the control list. The next big topic for today's PowerPoint is Atkinson and Shiffrin's modal model of memory. This model was very influential when it was first presented, as it summarized basically everything that was known about memory at the time. In this model, there are 3 distinct memory stores. Sensory memory, which Goldstein discusses in the textbook, short-term memory, which we're talking about this week, and then long-term memory, which we'll talk about next week. Basically, what this model was designed to do was to explain how information gets transferred from one memory system to the other. So how the information is transferred from sensory memory to short-term memory, and then from short-term memory to long-term memory. So the model includes the properties of the 3 different memory stores. It includes the information about how information gets transferred from one system to the other, and it also includes what causes information to be forgotten in each system. So let's begin by looking at a visual depiction of the model. As you can see, it's quite complex, so I'm going to give you a general overview of it first, and then I'll explain each part step by step. Remember, the model is attempting to explain how information is transferred from sensory memory to short-term memory to long-term memory. Essentially, it says that stimuli in the environment, like a list of words one is trying to remember, begins by entering sensory memory. If that information is attended, remember our discussion of attention from Chapter 4, that information is then transferred to short-term memory. Otherwise, unattended information is forgotten. Information that makes it into short-term memory can be stored in short-term memory through rehearsal, and rehearsal also transfers information from short-term memory to long-term memory. Unrehearsed information, like we discussed, is quickly forgotten in short-term memory after about 15 to 20 seconds. And finally, information is stored in long-term memory for long periods of time. When a memory stored in long-term memory is retrieved, it is returned to short-term memory, but over time some information from long-term memory is going to be forgotten. So now that we've seen a general overview of the model, let's look at each step individually. So to begin with, we're given some stimulus in the environment that we need to remember. Let's say a list of words. The first processing of that information will take place in sensory memory. Sensory memory is a very brief storage system for sensory information. Remember from the textbook that information can only be stored in sensory memory for about 2 seconds. So again, sensory memory will only briefly hold the list of words that you are trying to remember. The way information is transferred from sensory memory to short-term memory is attention, which remember is about focusing on information so it enters awareness. So attended information in sensory memory enters awareness, while unattended information is forgotten. Think back to the market scene in the change detection example. You become aware of the change in the color of the person's pants when you attend to his pants. That's when the information enters short-term memory or awareness. Otherwise, the color of his pants is quickly forgotten, so you don't notice the change. So yes, unattended information is rapidly forgotten. So if you're paying attention to the list of words you're trying to remember, that information will be transferred from sensory memory to short-term memory. But if you don't pay attention to the list of words, you won't even become aware of it. That information won't be transferred. Instead, it will just be rapidly forgotten. Short-term memory then reflects information that is currently in one's awareness. So yes, what you are currently thinking about is in your short-term memory. So when you become aware of the list of words and you are actively trying to remember them, that information is in your short-term memory. Now, there are 2 things that rehearsal does. It first transfers information from short-term memory to long-term memory, and it maintains the information in short-term memory. So remember, as long as you repeat a phone number that you're trying to remember to yourself, you can keep it in short-term memory indefinitely. So as long as you keep repeating the list of words to yourself, you can maintain them in short-term memory. Additionally, like we'll talk about next week, a good way of storing something in long-term memory that you need to remember later is to repeat it over and over again, to rehearse it to yourself. So yes, rehearsal also transfers information from short-term memory to long-term memory. At the same time then, unrehearsed information in short-term memory is quickly forgotten after about 20 seconds, so think back to the Brown-Peterson task that we've discussed before. And finally, long-term memory is the long-term storage of memories. Long-term memory contains memories for events that took place more than about 20 seconds ago. We'll spend all of next week talking about long-term memory. So the idea here would be that if you rehearse the list of letters you're trying to remember to yourself well enough, those words could be transferred from short-term memory into long-term memory, where you could then access them at a later date. When you recall a memory from long-term memory, what you are doing is transferring that information from long-term memory into short-term memory. So yes, retrieval from long-term memory involves taking the information from long-term memory into short-term memory, where you become aware of it then. And then some information in long-term memory will be forgotten, and we'll spend a chapter talking about forgetting in long-term memory in a couple of weeks. See the textbook for another example of Atkinson and Shiffrin's model, because I know this can be complicated. And as always, if you have questions, please post them in the discussion board. Finally, let's discuss working memory, which is defined as a memory system for the short-term storage and processing of information. What I want to do is to contrast it with short-term memory, which we defined as a memory storage system that is limited in terms of duration and capacity. So how are they different from each other? Well, there are two main differences. First, working memory is conceptualized as having many different parts. For example, the textbook talks about Baddeley's model of working memory and how there are 4 components to it: the phonological loop, the visual spatial sketchpad, the episodic buffer, and the central executive. On the other hand, recall from Atkinson and Shiffrin's model that there was only one short-term memory. The second difference is that working memory involves the storage and processing of information, whereas short-term memory involves the storage of information only. The reason that this idea of working memory was introduced was that many tasks we do require both storage and processing. Think about reading. Not only do you have to remember the words in the sentence to understand the sentence, but you also have to process the meaning of the words. So yes, some tasks like remembering someone's phone number after you look it up to when you type it into your phone involves storage only or short-term memory. But other tasks involve both storage and processing, so working memory. Here's one example of this distinction. Let's say I have you remember a list of numbers and repeat them back to me after a couple of seconds. So here's a list of numbers. Let's say I take them away, and then after a few seconds I have you repeat them to me. This would be a short-term memory task because it involves storing the numbers only. But let's say I give you a list of numbers to remember, and while you are remembering those numbers, I ask you to process them. So I ask you to subtract the second number from the first number, add the third number, and then multiply by the fourth number. This would be a working memory task because it involves storing the numbers plus processing them. All right, so that's all I have for you guys today. Have a great rest of the week.